We are looking at example 5 on page 90 of the workbook. Okay, and this is going to be our first example of using the integral test to determine whether or not a series converges. Okay, so let's read this together. They're asking us to give a formal proof that the series from example 1, series 1 over n cubed, converges. We kind of made a guess earlier when we looked at this example that it converges. We are now going to prove that it converges. Okay, so how does the integral test work? Well, the idea is just to look at the term in your series, 1 over n cubed, and to do an improper integral that has the same form. Okay, so we are going to integrate from 1 to infinity 1 over x cubed. Okay, same formula as the term in our series, and see if we can figure out whether that improper integral converges or diverges. Okay, so this is a calculation that we did a little earlier. We set this improper integral up as a limit. Okay, 1 over x cubed we can rewrite as x to the negative 3. Okay, and I'm trusting that you can probably take an antiderivative like this by now. So we take an antiderivative of x to the negative 3, we're going to get x to the negative 2 over negative 2, which I'm going to go ahead and rewrite as just negative 1 over 2x squared. Okay, that's going to get evaluated from b to 1. Okay, and continuing, if we plug in our limits, that's going to give us a negative 1 over 2b squared for the first one, minus a negative is a plus 1 over 2 times 1 squared, which is just 1 over 2. Okay, and the question is, what happens as b goes to infinity? Okay, well, as b gets bigger, this fraction, negative 1 over 2b squared, is going to get smaller and smaller, and it's going to go to 0. And so notice that what's left is just the number 1/2. So if you look at the integral that we started with, what is that telling us about the integral? Well, it tells us that the integral converges because we got a finite number when we took it. All right, and so what the integral test would say is simply that since the integral that we just calculated is convergent, then the series 1 over n cubed that we were given in the problem, that must also converge. Okay, so here comes our proof. All right, and basically we just need to put into one sentence kind of how we put this all together. So the basic idea is that since the integral 1 over x cubed converges, we know that the series must also converge. Okay, and the test that we used to conclude that was the integral test. All right, so that sentence that we just wrote, that is actually our answer to this question. Okay, so we're done with the problem, but let's make a few comments here. Okay, since we're relatively new to this idea of writing a formal proof, remember what's important when you're writing a proof again. So maybe just characteristics of a good proof, just to remind you. Okay, and you'll see that we'll do this in all of the proofs that we write. Okay, so we used a complete sentence. That's important. That's the way that mathematical proofs are written. So we took our calculations and phrased it as a complete sentence. Notation. Using notation correctly, that's also important. So if you look up at the work that we did, it was important to write these limit signs. So when we're taking a limit, being clear that that's what we're doing. Okay, and then when we wrote the proof, we made sure to write that summation sign because we were talking about a series. All of that's part of using notation correctly. And then finally, making it clear what convergence test we used. Okay, we stated explicitly that this proof is valid because of the integral test. Okay, and so as you write your own proofs,